Okay, so problem number 2. This is asking us to convert each equation to the form indicated and then identify x-intercept, y-intercept, and the slope. And that's basically what's going on for all of these, right? Okay, so here, this is what's called standard form. You have a number times x plus a number times y equal to a number. But they want us to put it in slope-intercept form, and slope-intercept form looks like y equals mx plus b, right? And then they want us to find the x-intercept, the y-intercept, and the slope, right? Okay, so we need to change this so we get the y by itself. So right now we have 6x plus 5y equals 20, but we want to get the y by itself. So that means we need to get rid of all this other stuff. So we need to take the 6x away. If we take the 6x away, we're closer to getting the y by itself. But what we do to one side of this equal sign, we have to do to the other. Now, that leaves on this side, these two cancel, it leaves 5y, and it equals, and these aren't like terms, we can't combine them. So we need to write them out, and I'm going to write the x term first because we want in slope-intercept for the x-intercept to be the x term first. So negative 6x plus 20, right? Now the y is still not by itself, it's being multiplied by 5, so I need to divide by 5 on both sides. What I do to one side, I do to the other. And on this left side, these two are going to cancel, and that leaves me y. And on this side, I need to divide the 5 into both parts, the distributive property, right? Now, I can get out my calculator and type in what negative 6 divided by 5 is, but honestly, I prefer slope as a fraction because then I can see rise over run. So I'm going to leave my slope as a fraction, negative 6/5 times x, because this is rise over run. And then plus 20 divided by 5 is 4. So now I have my equation in slope-intercept form. Now, you guys should know how to find the y-intercept and the slope now that we have it in slope-intercept form. So I'm leaving that blank. But we haven't practiced much in class finding the x-intercept. So I'm going to go ahead and do that one here, and you'll have to do it in the next one. Okay? So finding the x-intercept, the main thing you need to know about finding the x-intercept is when we want to know what the x-intercept is. Okay? That's something like where the line crosses the x-axis. Now, where the line crosses the x-axis, we always are at a place where y equals 0. And if we're always at a place where y equals 0, then we can just plug y equals 0 into our equations. It doesn't really matter which equation you plug it into, because they're both equivalent. But you need to just plug in y. So I'm going to use slope-intercept form. If I plug in y equals 0 here, I'm going to put 0 here. That equals negative 6/5 x plus 4. Then I just need to find out what x equals to find my x-intercept. So I'm solving for x. I'm subtracting 4 on both sides. Negative 4 equals negative 6/5 x. And then I need to get rid of this 6/5. You can divide both sides by negative 6/5, but that's the same thing as multiplying by 5 over negative 6, right? Multiplying by the reciprocal, so I'm going to multiply both sides times 5 over negative 6. These will cancel, and that leaves x on the left side. And then just use my calculator. Alpha y equals for fraction 5, negative 6, and then times negative 4. So that's 10/3. And I like that. You can see what it is as a decimal if you want, but notice with the decimal you end up having to round because you can't write out. So you could write 3.3 repeating, or you could write 10/3. So I'm going to write 10/3. It's your choice. You could also write 3.3 repeating if you'd prefer. All right, down here, they want us to take the y equals mx plus b, and they want us to put it in standard form. They also want us to find x-intercept, y-intercept, and slope. Again, you should know how to find the y-intercept slope from looking at this. You should know how to find the x-intercept. It's just like this. Remember, plug in y equals 0 and solve for the x. But the main thing that is new is this standard form, taking this and putting it in standard form. We haven't really gone over that. So what I want to do is standard form means no fractions, and it means that the x is going to be over here on the other side. So I'm going to rewrite this, and again, we're manipulating the equation so it looks the way we want to, and we can do whatever we want to the equation as long as what we do to one side we do to the other. So I'm going to add, I want to take this x and I want it over there. I want it gone from this side. So if I want it gone from this side, I can add 2/3 x, and this will cancel. Negative 2/3 and positive 2/3 will cancel. But what I would do to one side of the equation, I have to do to the other. So I'm adding these two together, right? And I could write y plus 2/3 x, but standard form has the x come first. So I'm just going to put the x first, 2/3 x plus y equals, and these are canceling, so that leaves 10 on the other side. But now, the only problem is I don't want a fraction. So to get rid of this fraction, I need to multiply by the denominator. I need to multiply by 3. 3 will make this cancel, and what I do to one side, I have to do to the other. So distributive property, 3 times 2/3, the 3's cancel, that leaves 3 times 2/3 is 2, so I have 2x plus 3 times y is 3y. And then on this side I have 30. So now I have this in standard form. So if somebody wants to look at the equation in standard form, this is the good way to go. If you want to look at it in slope-intercept form, you can go from standard to slope-intercept. Now on the back, notice what's happening now. What's happening now is you're supposed to be looking at it just in variables. We've got ax plus by equals c. But the same kinds of things we're doing can be done even if there's no numbers. So to put it in slope-intercept form, we still just want to isolate the y. It really doesn't matter what we have over here. The idea is still the same. Notice that what we did on number 1, we subtracted away this 6x. That was the first step we did. We subtracted away this thing that was being added to the y. And then the second step, we divided by what was being multiplied by y. So remember, subtract away what's being added, then divide away what's being multiplied. So we're going to do the same steps on the back here. We're going to subtract away what's being added. It doesn't matter what it is. It just needs to be subtracted away. What I do to one side, I do to the other. Okay, that means these cancel, leaving b times y equals. And then again, we just need to write these out. They're not like terms. I'm going to write the x term first, negative ax plus c. And then I divide by what's being multiplied by the y, and what's being multiplied is the b. So I divide by b on this side, and I divide by b on this side. Those cancel. That leaves me y equals. And then here, negative a over b, right? I'm dividing the b into both things. Negative a over b times x plus c over b. So now looking at this, you should still be able to tell what the y-intercept and what the slope is. And you should still be able to plug in 0 for y to find out what the x-intercept is. Now again, since this is a little bit newer, I'm going to go over it with you. But I want you to do the y-intercept and the slope on your own. It's not going to be a number this time, though. It's going to be variables. So back up here with the x-intercept, I just need to plug in 0 for y. And I'm going to show you doing it this way this time. Because on number 1, we plugged it in here. It doesn't matter which one. So I'm going to plug it in here. A times x plus b times 0 equals c. Now anything times 0 is 0. It just goes away. So we are left with actually a pretty simple equation. A times x equals c. And now I'm going to divide both sides by a. So x equals c over a. So what that's saying is anytime you have a y-intercept, anytime you have a slope, anytime you have a standard form and you want to know the x-intercept, you just need to take c divided by a, and that's going to give you your x-intercept. Let's see if that's true back here. For this one, if I take C, 20, divided by 6a, do I get my x-intercept? Absolutely. 20 divided by 6 is 10/3 or 3.3. So that's actually a faster way. Now that we know, now that we have these literal equations, we can use it to be faster. That's part of the nice thing about manipulating with variables. So here's some general equations. If you want to determine the x-intercept of an equation, which is more efficient, so you have to decide, is it easier to tell the y-intercept, is it easier to tell the y-intercept from the slope-intercept form, or is it easier to tell from standard form? You make that choice and explain it. If you want to determine the x-intercept, which form is more efficient? Is it easier to determine the x-intercept from this form or from this form? You decide and explain yourself. And if you wanted to graph an equation on your calculator, which one's more efficient? Which one's easier? The y-intercept or the slope-intercept form? You make your decision and decide and explain your reasoning.